All right, let's get started in the lab session for logistic regression. And I'm sure by now you have an idea what a logistic regression is and why we need to use logistic regression, even though we have a linear regression, but why we still need a logistic regression. Okay, so if you have gone through the previous video where we talked about the intuition behind logistic regression and the circumstance where logistic regression comes in handy, and even the logit function, right? I'm sure by now you are a bit familiar with logistic regression. So in this lab session, we're going to actually consider this Pima Indian data set, right? We're going to consider this Pima Indian data set, and it's all about diabetes, whether a patient is having diabetes or not, right? So we're going to build a logistic regression model which will help us to predict whether someone will develop diabetes or not. Okay, so that will be our main task in this particular tutorial. Okay, so we build our model and then we try to use our model to predict whether a patient has diabetes or not. All right, so let's get started over here. This is the previous example that we use when we're talking about the intuition behind logistic regression. Okay, so we start from here, and we have some features in the data set that we are about to take a look at. Okay, so let me first let's first show the data set so that we come back to see the various features that we have in our data set. Okay. So as I said, in the previous video, right? If you are dealing with your data set, the first thing you need to actually do is to actually import the various libraries that you're going to use. Okay. So in this tutorial, not different from the other tutorials too, we're going to first start by importing the various libraries that we need. Okay. And in this case, we're just going to use this PyForest over here, right, to import all the libraries that we need. All right, so I'm sure by now you're familiar with PyForest. If you've gone through the linear regression class, we talked about this, right? So you just import PyForest, right, with this single line of code, and then you'll be able to import everything else. You have to import them one by one, just like we did over here, right? You just have to import everything by one, okay, just like that. But if you use the PyForest, it will do that automatically for you, right? With all the other libraries, right, you to import everything for you. Okay, so we use from PyForest import star, that is import everything. Okay, and then in order for us to see the libraries that we've imported, we use lazy_import to get to know the libraries that we've imported. All right, so since this part is a bit familiar to you, let me actually collapse that part so that we will have space to work with. All right, so now the next thing that we have to do is to load the data set that we're going to deal with. All right, so the next thing we need to do is to load this, and this Pima Indians diabetes is a CSV file, right? It's a CSV file, so I'm going to use this read_CSV, which is present in pandas. Okay, I'm going to use that to read my CSV file. Okay, so since this is a CSV format, I use read_CSV to do that. Okay, so if it is in a different format, like say SL, then I'm going to use read_SL to do that. Okay, then after reading it, I store everything in my variable called df. Okay, so now moving on, I'm just going to use this df, which contains everything that I've loaded over here. Okay, which contains everything that I've loaded over here. Now let's take a look at the shape of the data set, which is the row, the number of rows, and then the number of columns that we have in the data set. Okay, so we can see that we have 768 records or 768 rows, and then we have 9 different columns in there, right? So if we take a look at the first 5 rows, right, if we take a look at the first 5 rows using the head function, right, and to help us to look at the first 5 rows. Okay, now you can see over here that we have this one is saying that we have 9 columns, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we have 9 columns as it's saying, and then we have 768, right? We have 768 rows, right? And we will not actually see all the 768 rows over here. We are seeing only the first we're seeing only the first 5 rows. So that's 0, 1, 2, 3, 4, right? That's only the first 5 rows over here. Okay, so basically this is our data set, and let's see the features that we have in our data set. So we have preg, right? And the description of our feature is saying that preg represents number of pregnancy, right? And plus represents, if we go to plus represents plasma, right? Plus represent plasma. And if we see say the press represents the blood pressure, right? Represent the blood pressure. And then if you see skin is nothing but the skin thickness, right? That's the skin thickness of the patients that come to the hospital. And then we have the test, right? And then the test represents insulin test, right? And then we have the mass, right? The mass is nothing but the body mass of the patients. And then we have the pedi. Okay, we have pedi here, and pedi represents the diabetes pedigree function. And then we have age, right? That is the age of represent the age of the patients that come to the hospital. And then we have the class, which is our target, right? We have the class, which is our target, which we are going to base on all these other features, right? All these other features to help us predict this class. Okay, so we have in the class column, we have one as diabetic, right? So if the person is having diabetes, we represent that person as 1, right? And if the person is not having diabetes, right, we label the person as 0. Okay, so if you go to the column, you can see that we have if you go to the class column, you can see that we have some 1s and 0s in there, right? So if the person, right, based on these features, if the person is having diabetes, or if the person is diabetic, we represent the person with 1, we label the person as 1, right? As I said, machine learning is nothing but the thin labeler, right? So it's always going to give you labels, okay? And then if you see this one here, right, it has been labeled as 0, meaning that this particular person, which is having these attributes, right, we're not it's not having a diabetes, okay? And this person, right, this person with these attributes, right, attributes here, is having diabetes. So if we encounter 0, we know that this person is not diabetic. If we encounter 1, it means that the person is having diabetes. All right, so let's move on and see if there were any null values in here, right? If there were any null values in here. So we're going to use is null over here, is null function. If you remember in the linear regression class, we use the isNA, right? We use the isNA.sum to see how many null values are in there, right? So in this case, we are also trying to use the is null, right? And then instead of .sum, you're using .values and then .na, right? So we're trying to be dynamic here so that you get to know all the different ways that you can actually expect when you're dealing with when you're doing exploratory data analysis. Okay, so in this case, what we're doing is that we're going to search to see if we find any null values in there, right? If we are going to find any null values in there. If we do that, you see that our results saying that it's giving us false, meaning that we don't have any null values in there, right? If we're to have true here, then we know that there are null values in here, right? So we need to be cautious when we are using this is null or is NA, right? Because is null is actually going to go through all these columns, right? Let me bring my pen here. It's actually going to go through these columns, right? Okay, it's actually going to go through all these columns, right? It's going to go through all these columns and see if it will find null values. And Python actually identify null values as N, A, N. So as soon as it encounters NaN, it will actually realize that it's a null value. But if it's not NaN, it's anything else, right? So mostly when they are preparing the data, different people have different ways of representing data that is not available. For instance, if we take this test column, right, things are a bit suspicious here. Maybe the patients that they couldn't test them, right? Patients that they couldn't test them, they represent that as 0, right? If you see the test here, if you see some of the tests, you can see that it's high value, very, very high value. So it cannot be 0. It cannot be 0. It means that those who were not present to be tested, right, were represented as 0, right? So that person who collected the data actually did that. And if you see the skin, for instance, you can see that there are some 0s in here, while some others are having a bit consistent values, ranging around, or maybe scattered around 20s and 30s, right? So something like that. But you can see there are still some 0s in there, which means that these were people who were not able to be tested, or the skin thickness were not able to be recorded. Okay, so those people were represented as 0, right? Those records were not available, so it's also represented as 0. But Python will not actually, if you use this is now, it will not be able to identify that, because what it will look for is this NaN. So if it is not NaN, it will just recognize it as a digit over there, and it will not actually say that it's not It's not now, right? So in this case, you have to use your own intuition to actually understand that in certain circumstances, some zeros are not supposed to be there, right? They are actually missing values that were represented as zeros. Okay, some could even represent it as question mark, as we saw in our linear regression class, right? It could be that. It could be that. So people have different ways of representing null values, and you have to be careful when you're dealing with null values, especially when you're using the is null or when you're using the is and a, right? When you're using the is and a function, you have to be very cautious. All right, so since now we have a bit intuition of this, right? So if we use the is and the is now here, then if we go with this is now, it means that we don't have any null values, but intuitively we have it over there. So we deal with that as we progress. All right, so what we're going to do is to plot a histogram of the first 8 columns, right? So we have this preg plus press skin test mass pedi and then age, right? So we're going to actually plot the histogram for that, right? So, I mean, except our target, which is class column, except that, right? So what we're going to do is to actually select the columns that we want. So we could have specifically select these columns, right? So like we could have just picked them as preg plus press skin test mass pedi age. We could have just select them over here as a list, but this is another way that we can also do it, right? This is another way that we can also do it. So in your DF, right? In our DF, what we're going to do is to select a range, right? Select it in a range, right? So indexing it in a range. So from 0, right? If I show you this way, right? Let me do it like this. Okay, so what we're doing is that if we talk about the index, right, so this one will be at index 0, this one will be 1, this one will be 2, this one will be 3, this one will be 4, this one will be 5, this one will be 6, this one will be 7, and then 8, right, something like that. And then that is positive indexing, right? If we talk about negative indexing, then it will start from the back. So this one is going to be -1, this one is going to be -2, all right? Okay, this one is -3, right? And then this one will be -4, this one will be -5, this one will be -6, -7, -8, and then -9. Okay, so if we use the negative index, then that is how it's going to be, right? So if you see what we are doing here, right? If you see what we are doing here, we are selecting a range of 0 to -1. So we start from here to the last but 1, because -1, don't forget that always the last one will not appear to, it's always going to be 1 minus the last one. So even if we do like maybe the range of from 0 to say 2, right? From 0 to, let me say 0 to 5, right? That is going to give us 0, 1, 2, 3, and then 4. Okay, all right. If we do a range of 0 to say 0 to 7, right? Then it's going to give us 0, 1, 2, 3, 4, 5, 6, right? So in the same way, if we want 0 up to -1, then it's going to give us 0 all the way to 1 minus this one, which is 0 to -2, right? So it's actually going to stop here. Don't forget that what we don't want to add is this column, right? So we're trying to get rid of that. Okay, so what is going to help us to do is to select from a range of this all the way to this part, right? All the way to this part, because -1 here, this -1 here is going to still be -1. So -1 minus 1 was going to be -2. So it's going to stop at the -2 index, which is this part. Okay, so we'll be able to select all this part of the in data frame. Okay, so that's what we want to select, and then after that we are going to use the histogram. We are going to use histogram to plot histogram for all these, right? And inside the histogram, the bin size of the histogram is 80, and then we are setting the size, which is 1250, right? And then the layout to be 14:4. So let me just go a little bit up, show you the result, and then I can actually reason to that. Okay, so this is what this means. So okay, so what do we mean by this 1250, right? So down here, right? So down here we're going to have this, right? We're going to have this, right? We're going to have that. That is going to give us our 12, and then we're going to also have this part, right? We're going to have this part, which is also going to give us our 50 over here. And then if we talk about this 14, right, 14 here is nothing but this. If we pick any of them, right, it's going to be 14 by 4, right? It's always going to be 14 by 4, right? It's always going to be 14 by 4, all of them like that. Okay, and then the bin size is actually this that you have over here, right, 80. So this is what we have now. If we let me get rid of this and then zoom in a little bit so that we can actually see it. If we see the various columns that we've been able to plot, right? If we take say let's take the age for instance, right? If we take the age for instance, we can see that the distribution of the age here is positively skewed, right? It's positively skewed, showing that most of the the patients, right, are having the age ranging between 20 and 40, or even if you want to go a little bit, right, between 20 and 50. While very few of them go beyond 50, right? So the patients that were included in this kind of data were were aged between 20 and then 50, right? With a very few of them who were aged beyond 50. Okay, so you can see that it's positively skewed over here. If we take the blood pressure of the people, you can see that it's mostly between 50 and then 100, right? It's between 50 and 100, with very few of them which are below 50 and beyond 100 over here. You can see if you take the pregnancy test over here, you can see that is also positively skewed, right? Where most of them are testing between 0 and then say 10, right? With very few of them which are going beyond that, right? The same thing for this pedigree here, right? And if you see say the body mass of the people or of the patients, you can see that it's actually almost uniformly distributed, right? With most of them having their age ranging between 20 and then 40, right? Most of them having their age ranging between, having their body mass ranging between 20 and then 40, right? With very few of them will go beyond 40. Okay, will go beyond 40. If you see the skin thickness, right, as we pointed out when we used the is now, right, it was telling us that there were no null values in here. Now if you see this part, right, the skin thickness, right, skin thickness, if they measure the skin thickness, it should be a tangible value. It cannot be 0. Okay, so if you see there are a lot of zeros in there, that's why you can see some spike over here, right? There are a lot of zeros in here. Well, the number itself, right, the thickness that they were able to record is ranging somewhere between say 10 and 50, right? It's ranging between 10 and 50. All right, while there are some zeros in there. As you can see, the same thing for the test, right? The same thing for the test over here. You can see that there were a lot of zeros in here, which was spiking here, whilst those that they were able to record were somewhere between 0 and between say 10, right? Between 10 and 250, right? With very few of them which are going beyond this, right? Very few of them which are going beyond it. The same inference you can actually infer from here, right? The same inference, the plasma, right, that you can infer. So you can see that most of them are clustered around 100, right? Most of them are clustered around 100, whilst they go a little bit beyond and then reach somewhere 200. Okay, so those are the values that we have in the different columns that we have in our data set. Okay, so moving on, this is what we're going to deal with, right? This is what we're going to deal with. So let's move one more step and then see what we can do over here. Now we can find the correlation that is existing among the various attributes that we have, right? Among the various attributes that we have, among the various columns that we have over here. Okay, so for that we're going to use just the call function, right? So this is the df contains our data, right? So we're using df.call so that we'll be able to see the correlation that is existing among all these attributes, right? Among all these attributes that we have in our data. So if we do that, right, if we do the df.call, this is what we have. This is what we have as our output over here. Now, one thing that we can actually notice over here, right? Let me get rid of that. One thing that we can actually quickly notice over here is that when we do the correlation, right? When we do the correlation, if you pick say pregnancy, right? Pregnancy is always going to be a perfect correlation, right? It's always going to give you 1.00. In the same way, if you pick say plus, right? Plus, that's a plasma, and the plasma is always going to be 1.0. It's going to be perfect, right? If you pick say the blood pressure and then the blood pressure over here is also going to be like that. Okay, so what what we're saying over here is that the diagonals are always going to be 1, right? The diagonals are always going to be 1, 1, 1, 1, right? That's a perfect correlation for the attribute and itself. And I mean, we are not interested in finding the correlation that is existing among an attribute and itself, right? It doesn't actually make any sense. So what we want to do is to find the correlation that is existing among, say, plasma and maybe skin, right? Something like that. So if we trace something like this, okay, let me change this. Okay. Okay, better. If we trace this for, say, plasma, and then skin, right? If we do that, we can see that we have 0.05, right? We have 0.05. That is, that is the correlation between plasma and then skin, which is a positive correlation, but it's very, very low positive correlation, right? So plasma and then skin are positively correlated, but it's very, very low, right? Very, very low positively correlated. Okay, so we can actually be safe for that, because sometimes when you find data points, right, if there's a high correlation among your various data points, that is a problem, right? You might run into something we call the multi, right? Something we will discuss about it, so don't worry about it, right? I'm just want to give you an intuition about that, right? We run into something we call the multi-collinearity, right? You might run into something called multi-collinearity. We'll talk about this when we get there, right? It's basically saying that if let's say it wasn't 0.05 and it was somewhere 0.8, right, which is very high correlation, right, which is closer to 1, right, approximately, right, closer to 1, then we can say that whatever information that one variable is giving you, and the other variable which is highly correlated with it is also giving you similar information, almost the same information. So you don't actually need to keep these two variables when you're building your algorithm. It's either you drop one or you find a way to actually merge the two, right? And when we talk about the principal component analysis, you also see how we are going to actually form principal components, right? You're going to actually see that. So all these are going to come into play as we progress in the course. Now let's leave this one, right? Let's leave that. We'll get to it when we get there. All right, now let's continue with what we're doing here. So let's say we have let's see the correlation between test and then pregnancy, right? So if we do that, we see that we have negative 0.7. So it's also negatively correlated, but it's very low, right? So mostly we have a very low correlation among all of them. If you see all the data points that we have, right, it's actually very low, right? If you see all of them, all the correlation that we have, right, it's very low. Maybe this one, which is 0.5, right? So a bit maybe age and then the pregnancy test, right, it's a bit correlated. And of course that makes a little bit of sense, because if the person, the older the person is, maybe the person is somewhere around the 30s or something like that, and we expect the person to be pregnant. So that is a bit reasonable. And if the person is too young, we expect the person not to be pregnant. And if the person is too old, we expect the person not to be pregnant. So age and then pregnancy test is actually going to be correlated, and we understand that one. One thing you need to take note of is if you're making analysis, or if you're doing this kind of correlation, right? You're finding the correlation that is existing among these attributes. One thing you need to note is that whatever values that are there, right? If we consider, if we take the diagonals like that, right, and then we pick the upper half, right? Whatever values that are here is the same values that are down here. Okay, so you can either consider either half of it and then make your analysis. Okay, so if you take, for instance, this 0.03 is the same thing that you can see here. Okay, this 0.17 is the same thing that you can see here. This value is the same thing here, right? If we pick, say, this one is just the same thing over here. 0.19 here is the same thing over here, right? 0.88 is the same thing that you can see over here. So the same values down here are the same values at the upper half of it, of this matrix. Okay, so you can take each half of it and then make your analysis on it. All right, so having said that and having derived some insights from that, we can now move on to the next stage of our analysis. Okay.